Hello and welcome to today's webinar, How Persistent Memory Delivers Superior ROI for Data-Intensive Workloads. This event is brought to you by Formulus Black, Lenovo, and Intel, and produced by Actual Tech Media. My name is David Davis, and I'm excited to be your moderator for this event. Now, we want this to be an educational event, so we encourage you to use the GoToWebinar questions box there to ask as many questions as you'd like. We'll be doing a dedicated Q&A session at the end of the event where we'll be taking the best questions that come in throughout, so make sure you get your questions in early. I also want to call your attention to the handouts box there where you can download the full slide deck of today's presentation. And at the bottom of that slide deck, you'll find a special slide that has a list of clickable resources that you can click on after the event and get tons of information on persistent memory and how it can help you in your data center. I also want to make sure that you know that we'll be announcing a prize winner on this live event at the end after the Q&A. That's where we'll be giving out our $300 Amazon gift card. If you're watching this event on demand, I'm sorry, the drawing has already occurred. The prize terms and conditions can be found on our website, events.actualtechmedia.com. And with that, I'm excited to introduce you to today's expert panelists. We have Mr. Jing Shi, a COO at Formulus Black, Mr. Jeff James, Director of Sales at Lenovo, and Mr. Steve Scargall, Technology Evangelist at Intel. Thank you so much, our expert presenters, for joining us on the event today. Before we jump into it, before I introduce you to the first presenter, here's what you'll learn on today's event. You'll learn what persistent memory is, what's unique about the Intel Optane DC persistent memory solution, what the Formulus Black FORSA application is, and how persistent memory allows it to deliver your applications incredible performance, and finally, how to test drive your applications with persistent memory. There'll be a special link at the end of the event that I'll paste in the chat box, and you can click on that to sign up for your trial and test your applications on persistent memory and just see what incredible performance you'll get. And with that, I'm excited to hand it over to Jing at Formulus Black. Jing, take it away.
Great. Thanks, David. Hi, everyone. I want to start by just thanking you all for joining us today. And, before we even dive into persistent memory, let's actually first talk about a term, latency. I'm going to do a fun little warm up here, and I'm going to quiz my colleague Jeff. Jeff, what would you say is lower latency, Prime or Prime Now?
I actually found over Christmas Prime Now made a big difference. Big difference.
Good answer. So I wanted to start with this concept of latency because I think it'll continue to come up throughout our presentation. And what this webinar ultimately is talking about is technologies that are new to the market that ultimately help bring down latency. In the case of Prime and Amazon Prime's business, they've continuously innovated on bringing down the latency that you experience in terms of using their products and services. And in the same way, many businesses today are playing the latency reduction game, even if they don't know about it or that they're not conscious or aware of it. But ultimately, it's about making decisions faster and delivering a better end user experience to customers. So ultimately, if you care about latency, you also should care about persistent memory, and this webinar is certainly for you. So with that, I'm going to go to a poll question. And the question to the audience is, what is your decision latency? Now, I'll talk about decision latency a little bit. It's really the time between something happening, your organization or your technology solutions being able to take the data that's being generated, turn it into information, and ultimately for a software application or an end human user to take action on it. So the concept of decision latency is quite broad, but it ultimately determines how fast and agile and responsive your business is. Now, I have a story that I wanted to share with you guys to really further illustrate decision latency. In 2012, I was working at IBM on a project in Africa. The government that we were working with was sending out hundreds of agricultural surveyors to thousands of farms across the country. And what they were doing was they were filling out paper surveys, taking them back to a data entry team at headquarters, who then spent about 3 months hand typing survey data onto PCs. Now, this whole process took about 9 months to finally generate data, analysis, and information that the government could later use to make large-scale agricultural supply-demand adjustments. This is a case of extremely high decision latency. And it put the government at a disadvantage because they weren't able to make data-driven decisions faster and earlier in the year. So long story short, we helped them develop a solution that was much lower latency. It involved no more paper surveys, and instead, the surveyors carried around Android tablets that could sync survey data back to centralized servers via the 2G and 3G telco networks in the country. And so, you know, just to kind of hit home this concept of decision latency, it's really a combination of multiple things. It's how you use technology and how you improve business processes.
Yeah, cool story,
How are
Jane.
the poll results coming out?
We have the results now. Let me go ahead and share the results of the poll with you. And so it said, 36% said basically they don't know. They're not really sure what their organization's decision latency is today. But 21% said days. It takes them days to get anything done, followed by weeks at 18%, and then third place there really was minutes. So what's your take on that? How does that compare to what you've seen?
Yeah, I think the responses are very interesting and very telling. And I don't want to steal any of Steve's thunder later in his section. So I will just say that the technology that we're focusing on in today's webinar delivers, far superior latency. And I think that given the decision windows that the audience is working with today, I think that, together with our software, Lenovo's systems, and Intel's new technology, I think it presents very interesting opportunities for companies to fundamentally improve latency. And so I will, so I'll spend just a little bit of time on this slide, but, just kind of going back to the West Africa agricultural project that I shared earlier. I think the area that CTOs, CIOs, and product leaders today have more control over is the types of hardware and software technologies that get utilized in their organizations. Organizational latency is kind of the business structures that be, and certain politics that maybe you don't have as much control over, but certainly. Again, hardware, software technologies that can dramatically accelerate data processing and reduce decision latency are areas that you all can influence in your organizations. Okay, so what are we doing, right? We've got 3 vendors on this call: Intel, Lenovo, and Formulus Black. You might think one vendor on a webinar is enough, right? Well, we each play a very distinct role in bringing persistent memory solutions to companies like yours. I think with the combination of our technology, we're bringing purpose-built software, systems design, manufacturing expertise, and cutting-edge new memory technology together as one solution, so that your business can decrease hardware and software-driven decision latency, and ultimately increase application performance for your most IO-intensive workloads, without having to rewrite any new code. So now I'd like to pass the baton over to Steve Scargill, software architect at Intel, to dive deeper on persistent memory.
Great, thanks, Jane. Appreciate it. So, let me just make sure we can click here. There we go. Thank you. So like Jing, I'd like to kind of start my section off with a quick polling question as well to the audience. And this one really pertains to asking more about your level of knowledge about persistent memory. So if we can run the poll.
Yeah, so I brought up the poll.
Yep, thank you.
And the question is, how familiar are you with persistent memory? And the answers range from, never heard of it, all the way to we're running applications or developing applications using persistent memory. While we run the poll, Steve, why don't you just give us a elevator pitch definition of, what is persistent memory?
Sure, I can certainly do that. So there are many terms that we use, persistent memory, non-volatile memory, storage class memory. You'll find them all pretty much scattered across the internet. Essentially, they're all describing a media that is byte addressable with load store memory accesses like DRAM, but they have the persistent property of storage. So the persistent or non-volatile nature of these devices means that when power is lost, the contents are kept. So in the DRAM case, when you power cycle your system, anything that was in DRAM is now gone. So you have to then rehydrate or page the data back in from your drives back into memory so you can begin processing again. Now the persistent memory devices themselves are installed on the system memory bus alongside DRAM and not on the storage bus such as your SSD. And I'll talk more about the different form factors later on in my part of this presentation. The ability for applications to access persistent memory media provides a convenient, or allows them to do this using memory mapped files, I should say. Operating systems such as Windows and Linux provide a convenient block interface and allow the use of standard file APIs such as open, close, read, write, etc. But the CPUs are always really talking to the persistent memory devices through their cache lines, only talking memory. So it's the clever bit of software in the middle that does all the manipulation between block and memory operations here. So hopefully that sets the scene for everybody. Yeah.
Yeah, it does. Very helpful. Let me share the results of this poll. And it looks like 57% said they've heard of persistent memory, but might not be too familiar with it. 14% haven't heard of it. This is the first time they're learning about it. 21% have done some research on it. 7% are running applications with it, and 1% are developing applications. What's your take on that?
I think this is pretty common. I mean, given how new persistent memory is, Intel only released the persistent memory product last April, so we haven't really been out on the market for even a year yet. But so we're definitely gaining momentum. But I'm happy to see that people are using persistent memory and are currently developing with it. That's great. But really, my part of the talk is really aimed at the people that have heard of it and would like to do more research into it. So that's great.
Okay, excellent. Well, back to you.
Thank you. Okay, that's great. So, I mean, we're all facing the challenge that, the volume of data is growing on a daily basis. And based on this recent survey taken by DataAge 2025, they estimated there was about 33 zettabytes of data currently existing in the world back in 2018. And they project by 2025, which is not too far away now, an increase up to 175 zettabytes. Now, 30% of that is the hot data. So that's the data that we would like to process either in real time or as in real time as possible. So the challenge is no longer about acquiring and building infrastructures to contain the data. We also need to focus on extracting the insights fast enough to achieve a sustainable competitive advantage. So, for example, real-time stock market trade analysis and forecasting, to more accurate product recommendation engines for online retailers, all scientists who need to process growing volumes of data for their models. So our world revolves around processing mammoth amounts of data as quickly as possible and understanding what that data is telling us. So removing infrastructure bottlenecks and aligning technologies to specific workloads is pretty essential for the business data strategy today. So the memory storage hierarchy pyramid, which is kind of showing on this slide here, depicts the current system architectures. At the top, we've got the CPU, which stores the data it's currently working on in registers. The CPU caches store data that the CPU either wants to process next or that it has processed and it's waiting for that data to be moved out to DRAM so it can be stored persistently on non-volatile devices such as your SSDs or your hard drives. Now, DRAM has low latency and has the advantage of being byte addressable, so the CPU can quickly and easily access the data within it. However, it's an expensive technology and has really limited capacity compared with the amount of data that we would like to process. So additionally, our data is lost, when the application or system crashes due to the volatile nature of this media. So, again, we have to kind of recover from that. So that's why we write the data out to our non-volatile SSDs, right? So that we can resume where we left off after the crash. Now, NAND-based SSDs have the capacity and cost structure to scale, but by design, they only offer a block granularity accessibility for our applications over the I/O bus, as they're intended for block storage manipulation versus memory operations like DRAM. So what we're doing here is we're really introducing high latency within the operating system I/O stack and the I/O bus and protocols themselves. And you can see really from this diagram that we create this gap between fast, low capacity DRAM and slower, high capacity SSDs and HDDs. So this is the bit that we need to fill the gap in so that we can accelerate our processing of data. Now, as Jing indicated at the beginning here, we now have a technology from Intel called Intel Optane DC persistent memory, or the Optane technology itself, that provides the persistence at a lower capacity cost than DRAM, with lower latencies and higher endurance than NAND SSDs. And the Intel Optane media is fundamentally different to traditional DRAM and NAND technologies, which makes it fairly unique. And one of the many benefits offered by the innovative Optane technology architecture is that we can deploy it in a variety of form factors that can connect either to the memory or to the storage bus to provide a wide range of memory and storage solutions. And now we're able to kind of complete this memory storage hierarchy pyramid, as you see here. So deployed as an Optane SSD, we can provide data access over the storage bus with significantly lower latency, higher bandwidth and endurances than NAND-based SSDs. Now, the performance characteristics of Optane SSDs deliver phenomenal block I/O performance for application workloads that are either I/O bound or I/O intensive. Now, implemented as the Optane DC persistent memory, we can provide applications with access to high bandwidth, large capacity, low latency byte addressable data, which is stored persistently, and that's the key here. So this technology is unleashing application performance like nothing else we've seen before. And we're no longer encumbered by the block storage models either. Applications can read and write data in place in sizes that are natural to the operation. So for example, if an application needs to modify an integer member of a data structure, it can modify those 4 bytes directly and update the data persistently. And, it doesn't have to read the 4K block from storage, perform the update, then write that 4K block back down to disk. Memory operations are far more optimal than block. Let's talk a little bit about the Optane persistent media itself. So this first generation, as I say, was released back in April 2019. And we offer capacities of 128 gig, 256, and 512. And these plug directly into the same memory bus as your DRAM. So each second generation Xeon CPU provides up to 3 terabytes of persistent memory plus whatever DRAM you want to put into that system. So on a typical 2-socket system, this gives us up to 6 terabytes of persistent memory, and we can scale this to 16 or 24 as we go to the 4 and 8 socket servers. Now, the endurance of persistent memory is very similar to DRAM, meaning less downtime and maintenance. We expect the product to last the lifetime of a typical 5-year production system. So the onboard controller manages all the wear leveling and error handling, etc., to help us achieve this goal. Now, the modules actually encrypt all of the data written to the device using AES-XT256 encryption. So you can optionally provide passphrases to provide even higher degrees of security for your data. Now, being on the memory bus provides us with the flexibility to configure the modules in 2 major modes. So let's look at those right now. So on the left there, we have memory mode. So configured in memory mode, we are presenting the capacity of the persistent memory to the operating system as volatile system memory. So Again, on a 2-socket system, if you had 6 terabytes installed, then the operating system would see 6 terabytes of volatile system memory. Now, the DRAM becomes a fast cache in this mode. So this is all handled by the memory controller and the CPU, so it's completely transparent to the operating system or to the hypervisor running on the platform. And you might choose this route in situations where you have applications that require, more larger memory capacities that you can currently deliver with DRAM alone at the moment, or maybe in a virtualized environment where you want to deploy more guest VMs than you can do today without over-provisioning the system resources. Now, on the right-hand side is what we call App Direct, and this is where both the DRAM and the persistent memory tiers are presented to the operating system to allow applications to choose how to access the data and which data to put in which tier. So to get the most benefit from persistent memory, applications need to be modified so that they memory map the persistent memory into their address space. And again, they can decide then which data lives in DRAM, in persistent memory, in SSDs, hard drives, or even back out to the cloud. However, there are many options for unmodified applications to also adopt this technology and take advantage of the persistent memory to accelerate performance. And this is where FORSA from Formulus Black helps deliver memory-like performance to existing unmodified applications. And Jing will talk about this in a little bit.
And Steve, I'm sorry to interrupt, but I'm curious, between the two different modes there, how do I choose one over the other? Is it just a matter of whether or not I have applications that, can leverage the application mode?
Yeah, I mean, unique to Intel Optane DC persistent memory, we do have these two modes, and we configure the platform to use either of them. There is an option to create a hybrid of the two models, but we typically recommend one mode only. And we set the system up either using a BIOS option or a utility called IBM CTL. Now, the decision as to which mode to choose is really determined by the application use case itself. So, again, is your application memory bound or constrained by the current DRAM capacity, in which case, if we gave it significantly more memory, would it be able to load all of its model data or working data set into memory and operate on it as a single entity versus working on it in chunks or paging data in and out all the same? Now, in memory mode, of course, the data is volatile. So when the system reboots, any data that was in persistent memory is now lost. Which might sound contradictory, but we basically treat it like DRAM. For App Direct, I mean, the data written is persisted, right? So that's really targeted towards applications, maybe like in-memory databases where you want to kind of persist the data versus having to rehydrate it each time the application on the system reboots. So yeah, we have a lot of big matrix and decision guides to help people understand which mode might be the correct approach for that particular application.
Okay, yeah, and that was a question actually from Roger, was how to choose between these. So we've got some good resources, and Intel has resources to help you choose.
Yes, Intel has resources. Your server OEM also has resources to help you decide which mode and how much persistent memory versus DRAM you need in a system. So.
Okay, and a question here from Hugh. He's asking what operating systems and applications support persistent memory in memory mode?
Oh, in memory mode? Well, in memory mode, it's completely transparent. So technically, any operating system or application should work in memory mode itself. There's no barrier to entry there. Actually, that was a great lead into this Ecosphere question because, during our development phase of persistent memory, we worked very closely with industry partners from the server OEMs to the operating system to applications. And you can see some of them on this slide here. It's a growing list on a daily, weekly basis. But to answer the question, in App Direct mode, you do need an operating system that understands persistent memory. And the likes of Microsoft Server 2019, Red Hat, SUSE, Ubuntu, most of the Linux distributions fully support persistent memory from the mainline kernel version 4.0 and above. Also from the hypervisor point of view, we list VMware there as well, but Hyper-V on the Microsoft side, KVM, QEMU also fully support persistent memory.
Okay, and that's actually a question from Michael that came in. Could this be used for virtual machines in VMware?
Absolutely, yes. VMware fully supports persistent memory in both memory mode and app direct mode.
Okay.
So yeah, it's a wonderful time to be part of this. I'll conclude here and hand over to Jing, but yeah, it's a very exciting part to see how we can accelerate workloads.
Absolutely, yeah. So I mean, you said, to use the application mode, you have to modify your applications, but can FORSA help us so that we don't have to make those application modifications?
Absolutely, yes. And I don't want to steal Jing's thunder, but yeah, to get the most benefit from persistent memory, applications should be modified. But to gain an advantage, we can use traditional off-the-shelf unmodified applications and use them very effectively and get 2x up to 10x performance improvement without having to touch a single line of code.
Got it. Okay.
So yeah, and that's where FORSA comes in. So I think that's a great segue into Jing's bit. So I'll hand it back to you, Jing.
Great, thanks, Steve. And yeah, great questions from the audience. I think that as a new technology that hit the market in 2019, persistent memory presents many new possibilities. And so, as was shown on the previous slide, there is a growing ecosystem of vendors and applications all up and down the entire stack that will continue to support persistent memory and take maximum advantage of it. Where we are focused today as a company is, think of us as a bridge. So Formulus Black, we've built a software stack that we call FORSA, and what we're focused on enabling you to do is to take memory resources on a server, so in this case persistent memory, and to be able to manage it and provision it so that any of your applications, whether modified or unmodified, can run in the memory channel and gain substantially lower latency and faster performance. Because I think over time there will be more and more applications that can directly support and take maximum advantage of persistent memory. And then at the same time, as we saw even in the survey results, a lot of people are still or just have started to take a look at this technology. And so our goal is to make it very easy for you to take existing applications, applications that you can't control the timing of whether or not they will support persistent memory directly, and we make it easy for you to run all of these on persistent memory media. And so the way we do that is we come packaged as a POSIX compliant block storage interface. So this is just a standard block interface that we built to provide applications with the standard interfaces that they expect to see from a read-write perspective. But we've done a number of very unique things along the way to enhance the usability, the data protection and backup capabilities, as well as we've done some additional tuning so that our block devices can deliver maximum performance on persistent memory. I wanted to just show you guys what does our product actually look like, right? How do you use it? There's two primary ways of using FORSA. So after you install our software on a system, you can manage and provision persistent memory resources through our browser-based GUI, which is what you see here. And then all of the different control functions for provisioning, deprovisioning, storage, VMs, doing backups, doing clones, doing snapshots, these types of activities, they can all be done as well through our RESTful API interface. So you can do things programmatically. You can also do things through our GUI. What you see here behind the scenes is it's a Lenovo ThinkSystem server with about 3 terabytes of Intel Optane DC persistent memory. And Lenovo's been a really good partner throughout this process as we've developed our software solution to support persistent memory. I wanted to ask Jeff if you've got any comments about our partnership so far.
Thanks, Jing. You know, it really is about FORSA, so I won't belabor it, but with the mix of people on the phone, you probably know on the call, you probably know it's not trivial to put together a solution like this. The value of Optane is really pulled out by the nature of a solution like FORSA, right? And so it's, you know, the common term of it takes a village. It's an investment. It's not just money or technology, it's people, and really a partnership in helping identify the problem and then helping kind of clarify how to make that market, how to deliver in that market. If you're aware of Lenovo, then you know this is happening already. If you're not aware of Lenovo, I would just challenge you to look deeper. We're happy to be part of the process, Jing, and for the Intel folks that are on the phone, thank you for the opportunity. But it's a small example of the commitment and then the value that comes out of the partnership. So again, thanks for the opportunity to be part of it.
Great, thanks, Jeff. Yeah, and it's been great working with the Lenovo team so far. I'll point out a few things here, more as teasers, because I'm going to cover some of the more advanced features and functions of our FORSA solution in later slides. But you'll see here that there's a 2x figure on the upper right of the dashboard. We have a unique way of identifying patterns in data, and the reason that you would want to use this feature is that for certain workloads where you do have more pattern in your data, we're effectively bringing down the cost per gigabyte or terabyte of using persistent memory as a fast in-memory storage media. And you know, simple examples of patterns that our FORSA software can detect on your system is if, for example, you're running multiple virtual machines on the same system, and perhaps they're all running off the same golden image operating system. We enable you to run multiple instances of, you know, let's say Red Hat, right, on a guest virtual machine, while only taking the storage footprint in persistent memory of a single image of Red Hat, even if you've got 20, 30, 40 of these instances running on the system. We call this bit marker data encoding, and it's a very unique feature that you know, comes with our software solution. And I wanted to also highlight that with FORSA, what is it that you're getting, right? There was a question about VMware earlier. So we're a purpose-built solution for provisioning and managing memory resources as fast storage on a server. And we give you the option of running your applications both at the host operating system level. We work with most of the Linux distributions. So if you have an application that you want maximum performance, you don't want the hypervisor in the middle, but you do want to run on persistent memory, you haven't modified it, right? But you still nonetheless want to run it much faster on persistent memory, you can use our software stack. You can provision our LEMS, which is what we call our memory-based block storage, and you can run them in the host operating system level to get maximum performance. You can also get great performance by provisioning a highly virtualized workload. We've integrated KVM as our hypervisor. And so just with a single server, you've got 3 terabytes of physical storage. And then effectively, what this is showing here is based on how the workloads and data that has been installed on this server to date, you may have as much as an effective 5.5 terabytes of capacity. So think about, you know, very large data sets that you're now able to run entirely from memory. Let's talk about performance, right? Because ultimately, this new technology is enabling you to unleash new levels of application performance for IO intensive, you know, data intensive types of workloads. In this case, what we've tested here and what we're showing is database performance. We ran the same benchmark. It's a TPCC benchmark for MySQL. And what we've done is we've measured transactions per second, which is a very, you know, common metric for database performance, as well as 99th percentile latency. And we've measured this performance across systems that have different types of storage. So on the very left, you've got an Intel SSD product, an NVMe class SSD. So not quite the Optane. Optane would be a little higher performing, but nonetheless, NVMe SSDs are, you know, a very high performance type of SSD product. And you can see that relatively running the same database on persistent memory, provisioned with FORSA's block storage technology, you're going to get almost almost just shy of 3 times the amount of transactions per second, while at the same time about a quarter of the latency. And so what this really means is on the same system, you're getting a lot more return on your investment of, you know, the CPUs, the workloads that you can run are much higher. What we're also showing as another baseline is actually provisioning DRAM, which is a volatile type of memory, but nonetheless our software enables you to provision it as a block storage interface, and just showing that as another type of performance baseline. And ultimately it comes down to TCO, right? So in the slide before, what we've done is we've taken those performance figures and we're putting it against, you know, prices of systems, and we've taken this off of in this case Lenovo's website, just configured these different systems with the different types of hardware form factor that were tested in the previous slide. And what you can clearly see here is that there is a price per transactions per second advantage to using persistent memory. That's the middle column here. You get much lower latency, you get much higher transactions per second, you know, using the same CPUs, and ultimately you're getting a TCO reduction in terms of database performance that is about, you know, twice as cost effective as the NVMe SSD configuration. And relative to the DRAM system, you are also getting a much better price performance. So this is a busy slide, but what we wanted to show here is ultimately, you know, what are you getting with just persistent memory and the system? What are you getting with a software stack that was built to add additional usability, data protection, and also some performance optimizations on persistent memory? And I'll start at the very top, which is, again, we're looking at MySQL as the database, and we've measured transactions per second using NVMe SSDs. The system with persistent memory without FORSA, using a standard Linux block interface that works with persistent memory. And we've measured transactions per second and latency. So as you can see here, there are some optimizations that we've done at our software level so that you get the best block interface persistent memory performance as possible. And again, no modification to your applications are needed. You get very low latency, very high transactions per second performance. And in addition to that, we have about a dozen features and functions that further enhance persistent memory. So if you're thinking about using persistent memory as that fastest tier of storage, you're going to want some of these additional storage features and functions. So things like block level snapshots, block level cloning, being able to expand a block device because it's running out of space. So let's, this could be a database application that's continuing to grow, right? You can do these types of things in a very easy to manage and non-disruptive way. And these are, I would say these are the more typical storage features and functions that you might find is, very common in the SSD product space. Then we've got a set of much more advanced features and functions. I don't want to spend too much time talking about it, but happy to go into additional detail as part of follow-ups for those that are interested. But I'll go through a few of these very quickly. So what is bad block detection and replacement? This is FORSA at a software level, scanning the memory region. And if it finds errors in the memory media, we're able to redirect I/O. And in other words, we're able to keep your application running even as different regions of memory may over time go bad. And so this is just it's a way to further protect your data, protect your applications that are running in a proactive way. You can also create backup and restore points very easily through a feature that we've developed called Blink. And think about this as a very fast memory capture, everything on persistent memory to either local SSDs or to a storage target. And as well as bit markers, which I've talked about a little bit earlier, but this is a data reduction technique. So again, bringing down the effective cost per gigabyte or terabyte of using persistent memory. And we also offer high availability. So if you've got applications that you've developed, in-house, and you want to keep them running, at all times because they're mission critical, we enable you to do that running on persistent memory. And so there's no development time needed to set up a high availability, cluster for your application. And lastly, we've done some interesting enhancements to our block device at a very low level in the software infrastructure stack. But to put it in simpler terms, our block devices are able to take advantage of multi-socket Intel server architectures in a very unique way and take the complexity away from your development team so that you can focus on engineering and application issues up the stack. And then finally, let's talk about capacity, right? Because ultimately, one of the benefits of persistent memory relative to DRAM is you get these very large form factor persistent memory modules. And so, with the work that we've done with Lenovo and configurations that we've tested, you can go anywhere from having a 6 terabyte to a 12 terabyte persistent memory system and enable you to run much larger applications that, in the past you may not have thought was possible entirely from memory. Okay, so I wanted to also double click on an additional capability here. So one of the things that Optane DC persistent memory does on its own is this thing called encryption at rest. For those of you who may work in industries where data security, any sort of theft of data is highly sensitive, there's an additional aspect to how our software is built and how our features work that add another layer of data security and theft deterrent. And the best way to describe this is how our bit marker encoding feature works is we're actually encoding the data that then gets persisted on the memory media. And so not only do you get, at certain times, you get the benefit of being able to persist more data in memory, you also have a software level data encoding that discourages people from doing things like trying to blink backup the FORSA data from memory to an SSD and then take the SSDs and run away with it. They would still need to have FORSA installed on another system that they install the SSDs back into to try to decode that data and make use of it. So there's, this is not an encryption technology, but this is inherent to how our software was built, and it adds a level of data security to those who work in industries that are very sensitive to those things. Okay, advancing the slide here. So now you're probably wondering, great, how do we actually trial or deploy your software? Well, there's three primary ways. One is as a software-only solution, and how we work here is that we're also backwards compatible a few generations back in terms of the Intel server families. For systems with Haswell, Broadwell, and Skylake, we enable you to take DRAM and provision it as a block storage media for the same, similar reasons of accelerating application performance. And I would say this is a great way to accelerate certain legacy workloads, as well as use that as an opportunity to understand what types of performance you can achieve by upgrading to the new Cascade Lake systems and deploying persistent memory as that storage tier. We also come as a FORSA preloaded server solution. So we work with partners such as Lenovo to develop a set of reference hardware that we've done additional testing and certification on. And what you get once you place that order is you get a system that's already got our software running. You turn it on, it's got the dashboard that you saw earlier, and you can start setting up your in-memory environment right away. And then as a third option, our software can run and be deployed in various clouds. Today we run on the bare metal types of clouds. So Packet is an example of a pretty well-known, fast-growing bare metal cloud provider. I think they actually recently they've just recently been acquired by Equinix, and other bare metal cloud providers as well. So IBM SoftLayer is probably a very recognizable one for those of you familiar with bare metal cloud infrastructure providers. And so our software can also be run on these types of systems and enable them to provide an in-memory computing environment for your applications unmodified. All right. So this is, I think, our last this is our second to the last slide. And ultimately, if you're interested in testing persistent memory and also testing our FORSA software for persistent memory, we encourage you to go to our website. There's a big free trial button at the top right. You just need to fill in your information. We'll take a little bit of time to understand kind of what applications you're trying to run, what workloads you're trying to run. If we can help figure out which mode of Optane might make the most sense for you, we'll certainly do that. And again, we partner with Lenovo and Packet so that we make it as seamless and frictionless for you to try persistent memory and run your applications on them as possible.
Awesome presentation, Jing, Steve, and Jeff. Really cool stuff. We have a ton of questions actually coming in from the audience here. So, I mean, there's some comments, things like, yes, encryption at rest. Dan said, fantastic solution. So a lot of good feedback, but let's just kind of go down the list here. And before we do, I want to point out to everyone that I've gone ahead and pasted that URL that you see on the screen there to request your free trial of the FORSA and persistent memory solution. I've pasted that into the chat box, and that's a clickable link. So you can just click on that, bring it up in your web browser, and then after the event here, just fill out the form to request your free trial. So let's go down the list. First one, George is asking, does persistent memory increase power consumption? Steve, do you want to answer that?
Yeah, I can take that question. So our persistent memory actually operates at various power levels. Obviously, there is some power requirement to drive these things. We operate each module either at 12, 15, or 18 watts. So yes, any server OEM that supports persistent memory has enough cooling and everything else to support running the product at full power if need be.
Okay, nice.
Yeah.
A question here from Michael. He's asking, is this only available for physical servers? Jane, do you want to? I think you covered that.
Yeah,
But do you want
that's a great question. Yeah, no, that's a great question. I can definitely take that. We've already had conversations, and there is certainly a level of interest in not necessarily deploying an entire bare metal system with persistent memory. But if I understand the question right, I think the ask is is there a virtual machine option powered by persistent memory? So the answer is yes, we can do that for you. I would encourage you to put some of those details in the free trial, tell us about your environment section. There's definitely been interest in, I guess, so-called general purpose compute instances with persistent memory as a storage media.
Okay. Okay, nice. Good to know that
If
option.
I didn't understand that question correctly, feel free to re-ask it just in case. But hopefully, I got the gist of that.
Yeah. Question here from Doug. He's asking, what's the CPU core utilization requirement to run FORSA?
The CPU core utilization requirement. Okay, so first off, we can support older systems back to the Haswell family of processors. The requirement there is that you need to have at least 256 gigabytes of DRAM capacity so that you can install our software and have some amount of effective space for both system memory and actually a separate space for the block storage that you want to run in memory. We don't have a core count requirement. We work with all of the Intel CPUs within each of the families. But if you want to take advantage of persistent memory, the memory modules, right, which is what our webinar has mostly focused on, you will need to be running with the latest generation Cascade Lake family CPUs. Hopefully that answers your question. Okay. Steve, feel free to chime in if there's anything to add there.
Yeah, and just to kind of tag on. So you're right. I mean, everything's memory operations at the end of the day. So from the communication point of view between the CPU and the memory or the persistent memory, there's no change as to where you are today. I think probably the question might be the software overhead, Jing, from your side as to how much CPU utilization they would need. But from what I've seen, it's almost or imperceptibly low. So it's not going to impact your application performance in any way.
Yeah, thanks, Steve. Yeah, and I guess just to reiterate that point, a lot of the R&D in terms of what are we spending time on, right? With when we say we're developing FORSA, a lot of the R&D has been being a very clean, minimal interface, so that while we're still presenting block storage to the application, it's able to very effectively handle your I/O, right? And we will not necessarily be as fast as an application that you've custom built or custom developed, where you're doing everything byte addressable. But for a wide range of applications that we've tested, you can get very good performance, and all these different bells, whistles, features, functions that I talked about in some of the earlier slides. Those come at very little or no performance overhead.
Okay, good. Another question here. Chris is asking: is it safe to say if you had servers with persistent memory and the FORSA software, you would need fewer servers?
I can start here, but yes, that is one advantage of persistent memory in general, but certainly with adding FORSA to the stack, the TCO benefits are significant. Yeah, so if we can deliver improved performance, like Jim was showing with the MySQL numbers there, using fewer servers, absolutely, you'll gain significant advantage there.
Yeah, I love this audience. You guys are completely getting it. So there's an entire list of, call it, TCO reduction opportunities. I really just covered one, which is if you just want more transactions per second per box, we are the solution, right? You got to think about running on persistent memory. If you've got database workloads that you want to consolidate, absolutely. And then the other consideration is as well from a storage capacity standpoint. We also may be able to help you consolidate, your server environment, because if you are running workloads where we see a lot more opportunity for the bit marker encoding feature to take advantage of patterns, while you may have a system with only 3 physical terabytes of persistent memory, you may actually have a system that is effectively keeping or persisting 4, 5, 6, or sometimes even multiples of that of raw data that our software is able to see patterns in. So certainly, even from the storage aspect of keeping more data on the same system, I don't know that there's too many vendors out there that have the ability to, in real time, inline, look at patterns in data and help you to ultimately increase the storage capacity of memory.
Okay, nice. There's a couple questions here from Shane about the lifespan of persistent memory. Does it have a read-write lifespan, such as a solid-state drive? Steve, do you want to take that?
Yeah, I can take that. So yes, I mean, it does have a lifetime. It's significantly higher than a traditional land SSD. If you go to the Intel website and look at the product specification, you'll see we're upwards of 300 petabyte writes. So we expect the persistent memory to last the lifetime of a server that is in production for typically 3 to 5 years.
Okay.
And if I could, I'll tack on to that even a little bit more by talking about again, going back a little bit to the bit marker capability. One thing to think about here is, in addition to the increased durability of persistent memory relative to most of the SSD products or all of the SSD products in the market, the way we do data reduction is fundamentally unique. And what I mean by that is, most data reduction techniques require you to write the extra data, the copy, the extra ones and zeros that you want to compress. The way we work is you never have to write that extra copy of data. And what that means from a wear and durability standpoint is that this is a software feature that actually further enhances and extends the life of this type of media. So maybe you might even be able to get away with even a longer effective lifespan for the server.
Very nice. Very nice. I know we're running out of time here. We're coming up to the top of the hour. So I think this is probably going to have to be the last question, and then we'll pass the remaining questions over to the presenters. Seth is asking, what's the time frame to install FORSA? What's the requirement to get it up and running, and how much data can FORSA handle? Jing?
Sure. So what you would want to start with is a clean install of Ubuntu, CentOS as an example. So if you're starting with a clean install of a Linux host operating system, the installation time of FORSA is typically 20 minutes or less. Might take you some time to download our installable, but other than that, the installation process is quite fast.
Very nice. So once someone clicks on this link, or the link that I put in the chat box, they go to the form, they fill it out. Can you kind of walk us through what happens after that?
Yeah, so persistent memory is new. We are happy to just be eyes and ears consultants. If you've just got questions about, hey, is it going to be good for this type of application or use case, or hey, I want to chat about memory mode, maybe we'll pull Steve in if we get some really hard questions. But ultimately, what we want to do is have a quick consultation, because one is we want to make sure that we are making the best use of your time. And if there's certain use cases or workloads where we've tested it and the results are great, we're going to say absolutely, let's move forward, move into a POC, make sure that we can validate the performance in your specific case. And if you've got use cases where there's actually a better alternative, we're happy to just suggest that as well. Again, sometimes what you'll find is some folks we've seen, they're really thinking about running Optane persistent memory in the memory mode. And that's not something that today we're doing anything with. So if we find that, hey, look, you're actually talking about running Optane in memory mode, we're going to say, look, you just here's our partner Lenovo, but you don't need our software for that. If you are using it for fast storage, that's when to think about us. Fast storage, unmodified applications, homegrown applications that you don't want your developers spending their time on because you have new projects. These are the types of things where we're just a very easy on-ramp to running applications from persistent memory.
Okay. All right. Excellent. Well, before we go, I want to announce the winner of the $300 Amazon gift card that is going out to Seth Pierce of California. Congratulations, Seth Pierce. And I also want to call your attention to the links that are on the screen, all these resources. If you download the handouts that are in your audience console right there, there's a slides PDF. It'll have links to all of these, as well as the URL to test drive the FORSA solution and learn more about persistent memory. I'm afraid we didn't get time for the many questions that came in, so we'll have to get back to you on those. Thank you so much for all the excellent questions. And also thank you, Jing, Steve, and Jeff for being on the event today.
Thank you.
Thank you.
Yeah, thank you, David.
All right, and thank you everyone in the audience for joining us. We'll see you next time. Have a great day.